Hello and welcome to Intervals Part 1, or How We Learn to Love Seconds and Thirds. Today we're going to be talking a little bit about the building blocks of theory. So, music. The language of music is comprised of notes, otherwise known as fixed frequencies of sound, but we'll get more to that in a little bit. These notes, they're represented on a music staff, the 5 lines with your clef, and when you put an individual line of notes together, you create a melody. If you take a bunch of notes and combine them all at once, they're going to create consonant or dissonant sounds called harmony. And believe it or not, philosophers and scholars as far back as Pythagoras and Aristotle, way back in ancient Greece, have been developing ways to mathematically represent these harmonic relationships in order to standardize how music is notated and then how it's performed, how you can write it more effectively. Now, yes, it is that Pythagoras, so you can imagine that he's going to be relating them together in the ways of math. So he starts with the idea that we have to describe the distance between notes, and the distance between notes is called an interval. So Pythagoras is among the first people to develop a true mathematical relationship to explain these intervals. He realized that any note is the result of something vibrating at a certain frequency. Think of vocal cords or strings or columns of air. And then each note can be specifically described by how quickly the vibration moved. So slower vibrations are going to produce low notes or low tones, and higher vibrations, faster vibrations, are going to make higher notes. And then this high and low can actually be calculated, and each individual note can be given a name or a pitch. So what he does is he sets himself to the task of finding the exact frequency of each note, so he can call it a certain name or a certain pitch, and then he tries to figure out the mathematical relationship between these various notes. So he develops a set of equations to describe this. And he starts by finding a note. So we'll call it X, right? We're doing math. So note X. And he figures out how fast the vibrations are. So essentially what all music is something vibrating at a certain amount per second, called a hertz. Right, so cycle per second. And he figures out his first note, his X, and then he says, okay, well, what's another note that's very pleasant if it's played at the same time? And it works out that it's a note that's a fifth away. So if you start on an A, that would be the note E, A, B, C, D, E. It's 5 notes away. So he starts on that note X, he finds a note that's a fifth away, and he just does the math. And he sees that the ratio is 3 to 2. So in our case, the A, which would be like a normal tuning note for an orchestra, is 440 cycles per second. So it vibrates 440 times per second. And an E, 5 notes above it, would vibrate at 659.3 something cycles per second. And if you crunch that math, it's a ratio of 3 to 2, or 1.5 times faster. And this works out really well. The valleys and peaks of the sine wave match up, and it sounds good to our ears. So what he does next is that he finds a note that's a fifth higher than that, and then the fifth higher than that. And he keeps going, and he keeps going. And he goes until he runs out of notes, and he begins to start over. And he marks all of these numbers down, and he has all of his frequencies. Now, as he does this, he's going higher and higher pitched. So it doesn't make a full scale, starting on an A going to the very next one. It's much higher. So in order to fill in the blanks of all the other notes that he's missed, he just multiplies or divides those frequencies that he's gotten by 2. So for example, if you start with that tuning note A, 440, if you want to know what the hertz or the cycles per second, the vibrations, an octave higher than that, you just multiply it by 2. So your A is 440, an octave higher is 880. If you start on that same A, 440, and you want to know what one octave lower is, it is 220. And then below that, it's 110 and 55, etc. So it's a very nice mathematical relationship. So this turns into a lot of math real quickly, and eventually you can find all of the very specific ratios between all of the different intervals, but it gets to be a bit crazy, and for all intents and purposes, musicians today, they don't need to know these numbers. They don't really think about it, and they don't have to. but some people do, like sound engineers, primarily sound engineers. So think of people who make digital instruments, those digital pianos. They need to know how fast these notes vibrate so they can calibrate all their pitches on the pianos. Also, people in studios need to know that way if they're recording something, they pick up hum from a guitar amp or something, that they can say, oh, that hum is around 55 hertz. And then in their equalization, they can actually edit out very specific frequencies to make the noise stop. And then practically in a rock and roll or R&B or hip hop or any sort of vocal studio, they know that, okay, well, this is supposed to be the note A, but the person who sang it didn't quite hit it in the right pitch or the right frequency. So they can take the note that they did sing and actually adjust it and make it hit the right frequency that it was supposed to be in. That's how we get auto tune. But since most of us are not sound engineers, what do we really need to know? Well, before we know what we need to know, we have to realize that the Pythagorean system, when it was created, it worked really well. It's a great idea. However, when you start putting it all in one octave, it creates some uneven sounds and some things that didn't sound quite right. So eventually, a different system was implemented so that each half step was equally spaced. So everything sounded the same. And that's what's still used today. So this was developed a few hundred years ago. Think of Johann Sebastian's Bach piece for the well-tempered clavier, preludes and fugues in every single key. He was among the first to utilize this new tuning system. So we use this today. All the half steps are equal. So what musicians today need to know is that the distance or the interval between each half step is equally spaced, and that there are 12 of them within one octave. And then each note within that has a relationship to one another thanks to its interval. So let's talk intervals. The basic interval, or at least the concept of the basic interval, is very, very simple. Basically, we're just going to count every note from one note to another. So, for example, if we start on a C and go to a D, that's the interval of a second. C, D. 2 notes, intervals a second. So if we go from C to G, then, again, just counting C, D, E, F, G, that's the interval of a fifth. And another example, going from C to B would be a seventh. Again, just counting C, D, E, F, G, A, B. 7. But a lot of people will see this and go, yeah, wait a minute, but we're missing something. And we are. This basic principle is very straightforward, but we have to start thinking about the pitches in between the natural notes. In other words, the sharps and the flats. Because think of these seconds. We could have a C going to a D, that's a second, but we could also have a C going to a D sharp. Now, because it's going from one letter of the alphabet directly to the next one, that's still a second. But now that we've added the sharp, we know that it can't be exactly the same. And similarly, we can go from C to a D flat. And yes, that's a second also, but now we have a flat. So it can't be the same as the D sharp or the D natural. So these are all the second, but we have to be more specific about what kind of second it is. Think of it like a last name. Last name might be Smith, but we have to know which Smith. So the way to be more precise with the description of an interval is to first realize that there are those fixed amount of half steps between each note. So between C and D, there are 2 half steps. We can go from C up to C sharp, that's 1 half step, and then C sharp to D, that's 2 half steps. Between C and D sharp, there are now 3 half steps. You have the first 2, C to C sharp and C sharp to D, but then we have to go that extra half step up to D sharp to make 3 sets of half steps. So go ahead, you try this one. How many half steps are there between C and D flat? Well, I guess first you have to remember that D flat and C sharp are the same thing. So with that in mind, you'll get 1. There's just 1 half step between C and D flat. So I guess that's the other big thing we have to remember. We have to know how all these notes work. Between almost every note, there's going to be a sharp and a flat, except in between the notes B and C, and between the notes E and F. They are always going to be just a half step between them. And think of it on a piano keyboard, there's no black note in between those, so we can see that that's exactly just a half step as it is. So here we have a chart with all of the notes, and you see in the center line there are all of our natural notes, A, B, C, D, E, F, G, A. And you see between B and C and between E and F, there's no notes. So there you see that they are a half step. So between each one of those blocks, reading left to right or right to left, it's just a half step. So they're all equally spaced. So if you read from left to right, the notes are going to be getting higher in pitch, and they're going to go forwards through the alphabet, A, B, C, D, E, F, G, A, B, C, D, E, F, G, etc. You can go backwards, of course. Music can go backwards. So if you read from right to left, these notes are going to get lower in pitch, and then, of course, backwards through the alphabet, A, G, F, E, D, C, B, A. Between each block, or each pitch, there's just a half step, and you can see that they're equally spaced. And then you can sort of just do the math. If you have a half step and you go to the next half step, skipping a block essentially, you're going to create a whole step because a whole would be the sum of two halves. Again, just going back to math. So there again, we see B to C and E to F, already a half step. Half step is the smallest interval between two notes here in Western culture. And then to create the whole step, like we just said, we're going to skip a block. Two half steps equal a whole step, right? Two halves equal a whole. So just for example, if we start on a B and we wanted a whole step higher than B, that would take us up to C sharp. B to C is a half step. C to C sharp is a half step. Two half steps equal a whole. So quick review. Intervals, they're not going to change because of sharps and flats, right? You're still just going to count letters, A, B, C, D. Regardless of sharps or flats, you're still going to use basic notes, alphabetical order for your interval. What's going to change is the quality of that interval. It's going to get more precise because we're going to start counting half steps. So like we saw, going from C to D, or C to D sharp, or C to D flat, they're all seconds, but there has to be a difference in the type of interval that the second is. So to figure that out, we need to know the half steps. To count the half steps, we're simply going from one pitch to the next. A to A sharp or B flat, they're the same note, it's just a half step. A sharp or B flat, up a half step takes us to B, so on and so forth. For example, the half steps going from C to D would take us from C to C sharp, and then C sharp to D, so two half steps. Would also be called a whole step because it's two half steps. And then if we went from C to D flat, that's just that first step from C to D flat, so one half step. And this is where we begin, the interval of a second. If you have an interval of a second, that's just one half step. It is called a minor second. So that's how we start to differentiate. We say C to D flat, that's a second, but because it's just one half step away, it's a minor second. So you can practice. What are the minor seconds higher than these following notes? A, D, and G. Here's your little chart of all the notes, so you can sort of follow along. So you're starting on an A, and you're going up to the next half step higher. Now it says a second, so we can't call it an A sharp because A to A, that's not consecutive letters in the alphabet. That's an A and an A. So we know it needs to go to some sort of B. So what B is there in the same block a half step higher? And we have a B flat. And it's going to be exactly the same concept. Starting on a D, you need to go from a D to some sort of E because it's a second. D, E, 1, 2. But it's only a half step. So you need to go just one block from a D, and that gives us an E flat. Starting on a G, exactly the same concept. Because it's a second, we're going a minor second up. We're going from G to some sort of A. And since it's a half step, we're going just one block, A flat. A couple more options for you. And you see that B and E have the asterisk. So this reminds you that, hey, you might want to be careful because we know that there are already just simple half steps between two sets of notes, and this is them. So if you start on a B and you need a second higher, it's going to be some sort of C because BC, 1, 2. But it needs to be a half step. But B to C is already a half step, so C is your answer. The same thing is going to work for E. E to F is going to be some sort of second, but it needs to be a half step. E to F is a half step, so that's your answer. So then if we start on that F and go up a half step, we get G flat. So it's all the same concept. It's just you're starting on a different note and then applying the same rule. Now we can have the interval of a second, but it has 2 half steps. So it'll still be consecutive letters of the alphabet, but now you have 2 half steps instead of just 1. And this would be called a major second. And of course, we can practice. There's our notes, A, D, and G. Here is our chart of all the notes. And now we need a second higher than A. So we know it's going to be some sort of B, but it can't be B flat because that's just 1 half step. It needs to be 2 half steps. So you go A to B flat is 1, B flat to B is 2. Starting on the D, we know it's going to be some sort of E because DE, 1, 2, that's the second aspect. To make it a major second, we need 2 half steps higher than D. And that would give us E flat, 1 half step, E natural, 2 half steps. I'll be quiet now and let you figure out G on your own. Did you get A? I hope so. Then we have our other sets. So again, be careful with B and E because we know that we're going from a B to a C. That's the second aspect. But if you only stopped at C, that's just 1 half step. You have to go 1 half step further, but it has to stay a C. So the only option in that next block that's a C is a C sharp. Go ahead and try E. Use the same principles. You get F sharp. And then starting on your F, you're going up a whole step or 2 half steps to the next note, which would be a G. So this idea of a major second is actually very important because almost all scales start with a major second, or another way we could say that is it starts with a whole step. And if we've memorized the pattern of whole steps and half steps, like in a major scale, for example, it starts whole step, right? Whole step, half, whole step, half. And that's really a major second. It's just another way of saying the same thing. Now, as important as these seconds are, the new thing, thirds, are even more important. The type of scale and also the quality of the chord that's played is actually dependent on the interval of a third. So to get a third, we're just going up 3 notes. So C to E, C, D, E. That's your 3 notes. But we can start thinking of it the same way. We can go C, D, E, C, D, E flat, C, D, E sharp. All of those would be a third. So before we get into all the complex stuff, let's just talk basic intervals. Just basic intervals, letters in the alphabet. What is a third above the given note? So you're just counting. A is 1, B is 2, C is 3. A third above D, D, E, F. A third above G, G, A, B. You get the idea. We're just counting. So go ahead, try these all on your own, counting 3 notes up. B, C, D, E, F, G, F, G, A. So now we see where these thirds are going to be. It's going to be somewhere in this area. But then we have to be more specific because there are going to be sharps and flats that factor into it, and we have to take them into account. So we can start to think through this logically. Because a third is larger than a second, 3 is larger than 2, it's going to make sense that there's going to be more half steps between the notes. With seconds, intervals of a second, we had 1 and 2 half steps. With thirds, we're going to start with 3 and also have 4 half steps between the notes. So for example, if you start on a C and go up 3 half steps, we get what we've mentioned before. C to C sharp is 1, C sharp to D is 2, D to E flat is 3. And you see that we went to E flat there, not D sharp. And that's because we're talking about thirds, not seconds. So if you have an interval of a third, you're starting in the alphabet and you're going A, B, C. You're going to 3 notes away in the alphabet. That's a third. But there's only 3 half steps. It is called a minor third. And that's where we get minor scales. That's where we get minor chords. And you can practice, of course. So what are the minor thirds higher than these following notes? It's our same 3. We have our same little chart. So you're going 3 spaces now, 3 spaces to the right, and 3 spaces because we're going up 3 half steps. So 3 half steps higher than A, that still makes it a third. So it has to be 3 half steps and also 3 notes away. And that would give us a C. you start on D next and go up 3 half steps, also making sure it's 3 letters away, D, E, F. And because that's right where the third half step is, there's your note, D to F. Now G to A, that's a whole step, but then you have to sort of circle back around, right? So G to A and then up another half step would give us a B flat. B, E, F. And again, we have the same thing. You have to be careful with those half steps with the B and the E. So we're going up 3 letters from B, but also making sure it's only 3 half steps. That would give us a D. Same concept with the E's, going up 3 half steps, 3 notes away gives us a G. And the same thing with the F. You're going 3 half steps away, but you're making sure it's the third letter. So you can't put a G sharp there because F to G, that's just 2. So it has to be a flat. So that's a third with just 3 half steps. We can, of course, have a third with 4 half steps. So if you have the interval of a third, going 3 letters through the alphabet, but it's 4 half steps in music, it is called a major third, just like major scales, just like major chords. And again, we can practice. A, D, and G. Well, we know from last time that A to C was your minor third. So you're still going to use a C, but you're going to raise it a half step to make it that extra half step away, making it a C sharp. D to F was our minor third, but then we have to raise it a half step, giving us F sharp. Same concept applies, but if you don't remember what a minor third above G was, you can go about it the other way. You can go up 4 half steps, remembering you have to circle back around, and going up 4 half steps, remembering that it's 3 letters away, we get B. We have our same worries about the half steps with the B and E. We're always going to have those worries. You always have to remember that between B and C is already a half step. So as you go up from B, counting up to 3, B, C, D, there's going to be your third. It's going to be some sort of D, but it has to be 4 half steps away. So if you count 4 to the right, making sure it's a D, we get D sharp. Same thing is going to apply with the E. You're going to count 4 to the right because it's 4 half steps away, but you're going to make sure that it's only 3 letters away, E, F, G. So the G that's 4 blocks away is G sharp. Last but not least, F and A. So the concept of a third, extremely important, probably one of the most important, because it is the relationship between that first note, the root note, and the third that gives us major or minor in our scales and chords. Seconds are also very important because it helps to add tension to harmonies, right? Typically, we think of minor seconds as being very, very dissonant, causes a lot of tension. Think of Jaws, for example. That's a very low-pitched minor second, creates tension. Now, with these two concepts, we'll take some time to practice these concepts. But also remember that there are 12 half steps in a full octave. We've only done 4, so there's going to be more to come. But for now, let's practice with those seconds and thirds. Get those sounds in your head. The half step, which is the minor second, whole step, which is the major second, the minor third, and the major third. And in the meantime, happy practicing.